The James Webb Space Telescope, JWST, is a space telescope which conducts infrared astronomy. As the largest optical telescope in space, its high resolution and sensitivity allow it to view objects too old, distant, or faint for the Hubble Space Telescope. This will enable investigations across many fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. If you want to know more about Elon Musk and his amazing projects, be sure to subscribe. Let's start. The U.S. National Aeronautics and Space Administration, NASA, led JWST's design and development and partnered with two main agencies, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The NASA Goddard Space Flight Center, GSFC, in Maryland managed telescope development. The Space Telescope Science Institute in Baltimore, on the Homewood campus of Johns Hopkins University, operates JWST, and the prime contractor was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. The James Webb Space Telescope was launched on 25 December 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first JWST image was released to the public via a press conference on 11 July 2022. Astronomers have found by using James Webb Telescope a radio galaxy with a diameter 100 times as wide as our own Milky Way, yet the finders describe it as being suspiciously ordinary in every aspect other than its immense size. The discovery highlights our poor understanding of these colossi and what drives their incredible growth, but it could provide a pathway to better understanding, not just of giant radio galaxies, but the intergalactic medium that drifts in the yawning voids of space. Giant radio galaxies are yet another mystery in a universe full of mysteries. They consist of a host galaxy. That's the cluster of stars orbiting a galactic nucleus containing a supermassive black hole, as well as colossal jets and lobes that erupt forth from the galactic center. These jets and lobes, interacting with the intergalactic medium, act as a synchrotron to accelerate electrons that produce radio emission. Not all the material in the accretion disk swirling into an active black hole inevitably ends up beyond the event horizon. A small fraction of it somehow gets funneled from the inner region of the accretion disk to the poles, where it is blasted into space in the form of jets of ionized plasma, at speeds a significant percentage of the speed of light. These jets can travel enormous distances before spreading out into giant radio-emitting lobes. This process is pretty normal. Even the Milky Way has radio lobes. What we don't really have a good handle on is why, in some galaxies, they grow to absolutely gargantuan sizes on megaparsec scales. These are called giant radio galaxies, and the most extreme examples could be key to understanding what drives their growth. If there exist host galaxy characteristics that are an important cause for giant radio galaxy growth, then the hosts of the largest giant radio galaxies are likely to possess them. The researchers, led by astronomer Martijn Nooij of Leiden Observatory in the Netherlands, explain in their preprint paper, which has been accepted for publication in Astronomy and Astrophysics. Similarly, if there exist particular large-scale environments that are highly conducive to giant radio galaxy growth, then the largest giant radio galaxies are likely to reside in them. The resulting images, they say, represents the most sensitive search ever conducted for radio galaxy lobes. Then they use the best pattern recognition tool available for locating their target, their own eyes. This is how they found Alcyoneus, spewing forth from a galaxy a few billion light-years away. Once they had measured the lobes, the researchers used the Sloan Digital Sky Survey to try to understand the host galaxy. They found that it's a fairly normal elliptical galaxy, embedded in a filament of the cosmic web, clocking in at around 240 billion times the mass of the Sun, with a supermassive black hole at its center around 400 meters. It could be that Alcyoneus is sitting in a region of space that is lower density than average, which could enable its expansion, or that interaction with the cosmic web plays a role in the object's growth. Whatever is behind it though, the researchers believe that Alcyone is still growing even bigger far away in the cosmic dark. That wraps up the video. If you liked it, be sure to subscribe.